Hi team, today we are addressing the task of as of now we don't have any message aggregation feature in AnyPoint MQ. So to achieve that we can use multiple techniques. We can store the we can subscribe to the NMMQ, store the value in object store, and then and once the particular limit is reached, we can publish upsert to the database or any other place. And we can do instead of object store, we can use an additional MQ for aggregation, and then we can consume it in another place so that we can easily handle the acknowledgements. And we can we can keep a for each of iteration 5, and then we can consume it multiple times. And then publish and then perform our aggregate all the payloads into a message into a variable, and then perform the aggregation operation. So let us see how as of now we are going to use object store with intermediate as an intermediate storage. So only we face problem like race condition means if you are using parallelly multiple objects are getting consumed, subscribed, so you will one thread may be updating the object store, another thread will be clearing the object store. So to avoid that, we use max concurrency, so that only one thread will be operating this one, and we can test the performance with multiple uh, objects. Let us see the sequence diagram. So we get the first, let us assume there are already two messages in the MQ, and we are receiving the third message. And we have a listener app here, um, HTTP listener with a contract saying the what are all the required fields, so that it will be there will be a standard among all the fields, all the APIs. So we are developing a audit log DB. So all the applications in our network, it's like 200 applications, will be interacting with this audit log DB. So we are keeping a system API for this one common API, and then we have a listener, and then we are publishing the message to the anypoint MQ and giving the success acknowledgement. We are decoupling the load here, and in the same application we are subscribing to the message. So we have the third message arriving it here, and we will be checking object store. We will be retrieving all the keys in the object store, all the values. So we will be getting the aggregated value, and since the message count is less than 3, we are aggregated message, we are updating the message. And if the message count is greater than 3, we are bulk inserting into the database. And in the same transaction, we are clearing the object store. Or else, if the values are less than 3, we will be updating the object store with the updated value. Okay, let us see the functionality now. Here we use raml for the standardization, what are all fields we require for the audit logging. So here we are considering source system, target system, interface name, source ID, start time, end time. The whole interaction, let us assume you have a SAP system interacting with SFDC, and the message SFDC ID is interacting back to the SAP system. We will consider the whole time here. Error code, in case of error codes, error description and remarks. It will we can consider this as an error handling framework as well. Okay, and publish it to the MQ. Now we subscribe it, and then we pull the Message is in the object store. Okay, now we we check the size of aggregated payload. We are saving this is a key, object store key, and we are saving this payload here in the aggregated variable, target variable. If the size of aggregated variable is greater than or equal to 5, we will be doing a bulk insert to the Snowflake database. We are updating the new payload which is retrieved we just got subscribed, and with the aggregated payload plus plus payload. So whatever the payload we are receiving here will be an array of single object, so that additional mapping will not be necessary. This will be an array of objects, and this will also be an array, and array becomes a single array of single objects, multiple objects. And once this is successful, we will be clearing the object store. Else, if the value is less than 5, we will update the object store with the respective key and the values. Uh, Let us see the functionality, whether it how it is working. Let us check the count, initial count, how much it is there. So we started with count 0. Let us go to the JMeter, and number of threads will be 1, loop count is 5. So total number of 5 requests should be sent to the external system, our Mule application. So I have mocked the payload here, what are all systems are there. Now let us send it to the system. Let us add one more. 6 more messages. Previously we have added 5. Now we are adding this 6. 1 second. Payload aggregation less greater than or equal to 5. Okay. Initially it will be 4, and by the time it reaches fifth one, we have the fifth message. It should be greater than 4 instead of 5. Fifth message will be there payload variable in the payload variable, and we will be receiving it. Previous object store values were cleared. We can go here, and then we have previous object store values were cleared, that we can see. And then, okay, and let us send 5 messages. So 5 records were inserted to the DB. 5 records were inserted to the DB. Let us check. Let us remove them. Remove the 5 records and do the bulk operation for this one. So number of 10 and then loop count is 5. So total 50. Let us keep it as 20. 20 users are hitting at a time in the iteration of 5. Let us see. Insertions are happening slowly. Let us check the counter. What is our thread group? 20. 5 into 20. 100 records were inserted to the DB without any issues. Thanks, team.